I'm Deebii, and this is my Explain Everything video about cooling water. The goal of this experiment was to determine the relationship between exponential, decay, and growth. To do this, we investigated the patterns of cooling water. What we did. First, we boiled water and poured it into a cup or mug. Next, we attached a probe to the graphing calculator, then stuck the other end of the probe into the cup of boiling water. Then we programmed the calculator to record the temperature every minute for 45 minutes. After waiting the full 45 minutes for the water to cool down completely, we collected the data, then plugged it into Sketchpad Explorer to form this graph. As you can tell, the graph represents an exponential decay relationship. We can see this from the downward motion the graph is taking. Now also, if we look closely at the points plotted, they do not perfectly match up the graph, and this is expected. In real-life situations, the points plotted do not exactly match the graph because there is no perfect growth or decay factor. Now moving on to the equation. If we look at different components of the equation, we can first start with y, which in this case represents the cooling of the water. And now we can look at the initial condition, which is 91 and 833 thousandths. Next would be the growth factor, but in this case the decay factor, which is then squared by x, which in this case represents time. Now if we take a second look, we can tell that the initial condition is the same as the y-intercept. Now this is common. The initial condition will always be the same as the y-intercept. And next over here we just have the table formed by Sketchpad Explorer, and we just have each point and the coordinates that were plotted. For this experiment we learned about exponential decay, how real-life results may differ from the planned ones we may see in books, and how we won't find an exact growth factor or decay factor, the different components of an equation and how they relate to the graph and what they share in common, the rate at which boiling water may cool down to about room temperature, and decay factors and how they relate to the graph, the equation, and the table. Thanks for watching.